Hi guys, I'm Pat Kelly. Okay, in this problem, they start us off with this function, g of t. And they ask us to find each function value for parts A, B, and C. And so what we're really practicing is this idea of function notation, which is huge. Make sure you master this. And function notation really comes down to the function that they give you. There's always some kind of argument. For us here, it's t. And then the algebraic expression, which is your definition of the function, it's always given to you. There will be t's in it. And what we want to do in each problem then, like if I look at part A, you take the argument that they give you and you just put it in wherever you see a t. So for this first part, I'm just going to look to that g of t function assignment, but wherever I see a t, I'll replace it with a 2. Okay? So this will equal, and I'm looking at the original function. There's a 4 as a coefficient. Then it's t squared, but my argument is 2, so I'll put a 2, even in parentheses if it helps keep you organized, but that's squared because the t was squared. The next thing in the function assignment was subtraction. I put a subtraction there. 3 times, again, there was a t, but I'm replacing all occurrences of t with my 2, my argument. And then there's a plus 5 back up here in the function assignment. Okay? Just real quickly, see how this hopefully looks just like the g of t function they originally gave me, but with a 2 everywhere that there was a t. Okay? And now you just clean it up. Always look to simplify. So in this case, I can simplify by doing some arithmetic. 2 squared is 4, multiplied by 4, 16. Subtract 6 plus 5. Let's keep going. 16 take away 6, but then plus 5 looks like 15. 15 would be my final answer for part A. Moving to part B. It's still function notation. Focus on that. But this time the argument is always everything that's inside the parentheses there. So t minus 2. That entire binomial needs to go into the original function wherever there was a t. Okay? So my first step in this part B is that this will equal, and I'm looking at the original function 4 to start. Then there was a t that was squared, so I'm going to put t minus 2. Parentheses again if it's helping you keep organized, which is a good idea here with binomials or anything bigger, but then squared. Let me keep going with the original function. Then I see subtraction. Then I see a 3 being multiplied by the argument, and the argument here is t minus 2. So that 3 is being multiplied by the entire t minus 2. And then there's a plus 5, plus 5. And I'll grab my other color here again just to show you that that's the argument. This overall expression should look just like the original, but wherever there was a t, I'm replacing that with t minus 2. Okay? Now back to this problem though, because you always want to try to simplify. So to simplify here, there's a little bit more algebra. I need to expand these parentheses, FOIL, and then I'm also going to distribute through that 3. Maybe it'll take me a couple steps, but then I'll collect like terms, try to get it as simple as I can. So 4 times, and what I'll do right now is FOIL. I'll take this binomial and multiply it by itself. What I should get is t squared minus 4t plus 4, close parentheses. Now I'll continue on outside of that binomial squared. There was minus. Let's push this 3 through. So 3t minus minus, always be careful. There's a plus 6, and there's still the plus 5 straggler. Don't forget it. Okay, now I'll distribute through this 4, and I'll get 4t squared minus 16t plus 16. Subtract 3t. And while I'm at it, I guess in this step here, 6 plus 5, so that would be 11. And we're almost done. I think one more step, and I'm looking to collect like terms. There's only one t squared term, so he stands alone. But there's a negative 16t and a minus 3t, so minus 19t. And then the two constants are 16 and 11, so plus 27. I think I'm cleaned up as much as I can be, and so that would be my final answer, okay? So it's not unusual to get answers to these function notation problems where you have variables still, okay? You're not always looking for a numeric answer like we had in part A. But. Okay, one last part, still the same concept though. I've got some function notation I need to address. So be careful with this one though. There are actually two different occurrences of the function notation. I'm just trying to point out that I have two different g ofs in part C, and it's very different than part B, where I only had one g of, even though there were a couple things going on the inside of the parentheses. That was just one incidence of the function notation. Go over here, two incidents of it. So I'll just take each one slowly. This will equal, and I don't know how slowly I need to go with this first one. G of t, my argument is t. It's exactly the original function. And technically, you could be putting that argument of t in wherever you saw t, but it's the same thing. So this ends up looking exactly like that given 4t squared minus 3t plus 5. Okay? If it helps, this square brace is getting replaced with this square brace. And I'm not trying to suggest anything with notation. I'm just trying to keep organizational schemes going here. That's just the first term in what they want me to find. To continue, there's a minus, so I'll subtract. And now I need to do g of 2. Again, function notation. G of 2 would mean to take the 2 and plug it in wherever I saw t in the original function. But this is really just coincidence. We already did g of 2. And we know that the final answer was 15. So I can get right to my value of 15 here, which again, if it helps, that replaces this set of square braces. Okay, pretty much done, but the square braces, again, just organizational schemes. So that's like parentheses, it's grouping symbols. Let's clean it up by getting rid of those grouping symbols, and as always, simplify. So 4t squared, it's the only t squared term anywhere. Minus 3t, it's the only t term anywhere. But the plus 5 minus 15 should combine, take you down to a minus 10. Now it looks like my final answer there for the third part of the problem. Okay? These are important problems. You need practice. Make sure you do plenty on your own. All right?